and turn this over to Mitch.
Thank you, James. Welcome, everyone. I appreciate the opportunity. So setting the stage a little bit, I appreciate James' glowing remarks. I began my career as a machinist. I went through an apprenticeship program and started off in the early days doing CAD/CAM and complex CNC machining. And I am really thankful for that hands-on experience, and I still get involved and get my hands dirty a lot today. As James mentioned, I've been an entrepreneur for a number of years now. I founded a CAD/CAM company in the 90s and sold that, and parlayed that into a company that some may know called MFG.com, marketplace for manufacturing. CEO and ran that business for 13 years. And then a little over a year ago, I just got really interested and saw opportunities with manufacturing in America, in the opportunity to not just talk about the technologies, but to put them into practice. And I founded a company called Ziki, which is a little over a year old. That name means nothing, by the way. It's just a 4-letter domain name that I own. And I wanted to take some of the technologies happening around CNC machining, 3D printing, new things around CAD/CAM, and put those into practice and actually practice what I was preaching and make parts. And that's what Ziki is. And on the right is some examples of things that we're doing, from building systems for medical companies to aircraft seats, jewelry, military devices, and robots that crawl through sewers. We're doing all sorts of really cool things. Now, this won't come as any surprise to probably the people on this webinar. But I'd like to start this off by talking a little bit about manufacturing and things that people don't realize. So when you look at a stapler is a stapler. People think it's a simple product. But in reality, there are a lot of manufacturing processes, a lot of design that went into just making a stapler. Right? It includes die making, mold making, screw machining, metal stamping, plastic molding, rubber molding, spring making, assembly, and logistics to get it. And that's why I'm so passionate about manufacturing. It's the world's largest industry. As we look around us, from staplers to the most complex things, everything is manufactured. And the digitalization and convergence of that digitalization just opens up tremendous opportunities for companies, for our country, for the world, and the economic stability of our lives and our nation. So when I talk about the digitalization of manufacturing, let's set the stage of what it is that I'm talking about here. And I'll use the term direct digital manufacturing, DDM. That's become a quite popular term today. And that's the convergence of 3D CAD, CNC machining, laser scanners, 3D printing, which is more commonly known in our industrial circles as additive manufacturing, Internet, and then the Internet of Things. As we go through, we're going to talk a little bit about each one of those and what the state of the art is, and a little bit about what's reality and what's hype. And again, I'll go back to the 3D printing term. We tend to think of 3D printing as a term used in the more consumer space, the hobbyist, the maker world. And we tend to use the term additive manufacturing where we're thinking about real industrial, commercial quality parts. So how real and how practical we're going to talk about, and then what's the state of the art. I'll start off with 3D CAD. Now, one of the things that's got me really excited, and something I'm using on a daily basis now for 3D CAD, is a technology by a company called Onshape. Now, Autodesk has a competitor to this called Fusion 360, which is good as well. I just happen to be using Onshape. What's really exciting here is Onshape is CAD in the cloud. A lot of you probably know or use SolidWorks. And so Onshape was founded by a lot of the original SolidWorks team. And you can now log in to any browser, start doing your 3D modeling, nothing to download, nothing to install. It doesn't matter if you're on a Mac or a PC, as long as you've got a browser and an internet connection. The things that become really interesting, you think about when you're designing in the cloud, which means you're connected natively, your entire ecosystem, the possibilities become really interesting. And we're using this at Ziki. It's a very creative ways as we collaborate with our customers, as we use it internally. And you can do all sorts of rights control and different things that you can do in the cloud that you haven't been able to do in traditional software. Yeah, and of course, upgrades are just cloud-based. They're instant, not automatic. And I think that this is the future of CAD. It's 3D, it's in the cloud, it's anywhere you are. It's very easy to share things, revoke the share access, collaborate as a team with your suppliers, and I think this is a very important happening or event that's happening in manufacturing that makes it industrial quality CAD more accessible to anyone and natively tied to a connected ecosystem. Let's look at CNC machining for a second. Now, CNC machining is not new. Obviously, it's been around for a long time. But the advancements have really sped up in the last couple of years, particularly around things like high-speed machining. And this has real-world impact on you and the products you design, because this high-speed machining has allowed us to cut cycle times on machining dramatically. And part of that was caused by a shift in the way machine tools are designed, from being very heavy, big cast iron pieces of equipment. They've gone now to more lighter weight, linear guideways, linear bearing type machines. And we're machining now is with extremely high speed spindles, extremely high feed rates, with very small cuts. And that's enabled by the control systems that are available today that can allow that very high speed movement with extremely high precision. So we're able to go from 3D model to toolpath faster than ever today. The CAM software and the way it integrates with CAD software is allowing us to import a 3D model, put toolpath on it, have it in the machine in a matter of minutes. So we are able to take the most complex parts and have those programmed in 10, 15, 20 minutes maximum. And it's an amazing shift in what used to take a day to program complex parts. So what all this has done with the high-speed machining, real-time probing, so that we're getting real-time feedback on the machines as we're machining it to hold tolerances, adjust, recut an area as cutters wear, is made low volume extremely economical where it wasn't in the past. You probably know, to get one-offs, to get 5 pieces made, 10 pieces made, very expensive. No one wanted to actually do that kind of work for you. And if you did get it, the prices were just crazy. That's not so today. It's very feasible now, due to the state-of-the-art with CNC machining, to get low volume and get it turned around fast. And lead times have now been reduced where customers expect days, not weeks, not months, that CNC machine parts turn around, and it's very possible. Now, around additive manufacturing, there is a lot to talk about, and there's a lot of confusion in the market. And there's a lot of low-end systems that I think have come about with one of the best technologies for real commercial parts is FDM. So that stands for Fused Deposition Modeling. Fused deposition modeling and selective laser sintering are probably the best two technologies for real end-use, commercial, usable parts. Parts that are approaching injection molded quality. There are a lot of other technologies that are very good for presentation and appearance, but not nearly as usable and durable. But the confusion becomes some of the patents expired on the fused deposition modeling. There's been a lot of companies that have created very cheap systems that you can buy for $1,000, $2,000, and it's careful not to buy one of those or see one of those systems produce a part and think that that is the quality that you can get from additive manufacturing. Because the commercial grade, commercial quality industrial systems are producing parts that are just amazing quality. And I think you're going to see a lot more companies now designing parts to take advantage of additive manufacturing and not spend the money on tooling, have an injection mold built, even if it's a short-run injection mold, for a couple of reasons. One is it locks you into that tool, and I see there's an extra O in there. It locks you into that tooling, and your design, therefore, is locked. So that's one of the beauties of producing these parts by additive manufacturing, is that there's no tax for complexity. It doesn't matter. You can all of a sudden design and think in a very different, more free-form way, not design with limitation of traditional tooling processes. So there's a big opportunity there. Now, additive manufacturing has moved beyond just a prototyping tool, which is what it's known for in a lot of cases. So where you can actually do short-run, low-volume parts, and it's economical at a very high quality. So I think some of the next technologies or next waves of innovation that you're going to see is in additive manufacturing is not really around improving part speed and quality so much. That's already pretty much there. It's quite good on the high-end commercial systems. I think you're going to see people figuring out a way to do this with scale and volume that meets the need of people that need to have 200 parts, 500 parts, 1,000 parts, and they need to have them pretty quickly. I think you're going to see that as probably the next innovation. And one of the things that this digital, direct digital manufacturing, whether it's rapid CNC machining, additive manufacturing with scale and speed, is enabling, it's helping solve a problem that's been this no man's land of manufacturing. And that's where it's in between a prototype and some volume where it made sense to build a low-end rapid mold. So maybe it's between 0 and 1,000 pieces. And there's been a lot of products that just didn't make it to market or haven't made it to market because the economics didn't make sense. Or there was going to be too much differentiation in the products, customizing to customer demands, customer tastes, and there just wasn't a way to bring it to market economically at low volume. That's changed today. And I think that's why you're seeing sort of a re-emergence of the cottage industry and niche products that never had been on the market before. It's because now it's very, very real and possible to do it with scale, with speed, and economically. But what are some of the challenges to overcome? You know, with direct digital manufacturing, things now get produced more on demand. They get produced more locally. Customers can increase their margins significantly by making their design so that the customer can customize them or have options. And that's where there is a lot of margin to be made. And a very simple example we can all relate to, something like Starbucks. When you go to Starbucks to buy a coffee, you buy a cup of coffee that you could get at the convenience store for $1. But Starbucks customizes that for us on demand and charges us 4 times as much for that. Product companies are realizing the same thing. If we can add some level of customization, we can break out of being a commodity product and increase our margins significantly. And direct digital manufacturing facilitates this. And it doesn't lend itself to making 1 million widgets all the same in a factory on the other side of the world. You have to harness its digital ecosystem and digital technology in order for this to be a reality. And then the other challenge I think to overcome is design thinking. I know at ZC we see a lot of parts people send us, and we'd like to have these produced in low volume by additive manufacturing. And I look at the part and I see that the engineers designed it for injection molding. They used the same exact constraints and design limitations as if they were injection molding it. And so we'll often go back to them and suggest, you don't have to do this anymore. We can make this wall thicker. We can make an undercut here. There is no penalty for having to add slides to a mold like you would for building molds. The additive manufacturing technology doesn't care about your complexity. Once that light bulb goes off, we see people begin to design products in a much more creative, free-form way. And it's really cool to see the shift in product design that's happening and being enabled by direct digital manufacturing. So, what to expect? I think you're going to see this speed and scale come into additive manufacturing, particularly around plastic parts. Now, the metals is actually quite good right now. Stainless, titanium, some aluminum. It's probably 5 to 8 years behind where plastic additive is. It's slow, it's expensive, but when you need it, you need it. And so it's now for parts that you just can't make any other way that you couldn't machine. But I think metals is going to be a really big frontier and do the same thing that plastics has done. Plastics is just a little bit 5 to 8 years ahead of metals. But in the plastics arena, the technology is mature enough at the commercial industrial level where you're going to see the speed and scale be the next level of innovation. And that's just going to allow people to have shorter product life cycles, which everyone wants. Products have very short time on the shelves today. You have to be iterated quickly. And then I think that's going to iterate, as we were discussing in the prior slide, mass customization for a global economy. And I think all of this helps reshoring, bringing jobs back to America, because all of a sudden making, as I mentioned earlier, making 1 million widgets at a factory in China no longer makes sense. That's a commodity business. You can't differentiate your product. And there's some analogies in history that are very, very applicable here. We can all probably remember how photographs got produced in the dark room. Then it migrated where we'd drop our film off at a local photo shop or a local drugstore and get it back in a week. And now we all print our pictures and we can do it with amazing quality. It really disrupted an entire industry. The same thing is going to happen, but I don't think on the commercial scale you're going to see people printing or additive producing their own parts from a commercial standpoint, and I think you'll see doing that from a hobbyist standpoint. Just like for your company, if you were to take a photograph and you want to print it out yourself at home, you can do that with extremely high quality. But if you want a beautiful brochure for your company, or you want to produce a magazine, you're probably going to go to a printing company that has high-end equipment, industrial quality. I think that same analogy is going to play out in the additive manufacturing space. Look at what the digitalization did to publishing. It's called the publishing industry, the media industry, tremendously struggled, have to reinvent itself. Again, another analogy to what's happening in manufacturing. I bring up these two examples because I want to be sure everyone pays attention to this and doesn't think it's a fad. This will change manufacturing. It will change how you need to design products and how your supply chain works. Now, this change is hard and messy. I'm going to relate a couple of little stories here quickly. From 1139, Pope Innocent II was ruling an area in Europe. There was a civil war going on. Both were fighting with swords, and there was this guy came up with a crossbow, and he went up on a hill and he just started picking people off with this crossbow. Boing, boing. Oh, so people put down their swords. They went to see the Pope, and they said, "We have to outlaw these crossbows. This isn't fighting fair." Well, the Pope did it. He outlawed the crossbows. And he said, we have to do this to stop the proliferation of weapons of mass destruction. Now, he was talking about the crossbow. Well, we see how well that worked. The Luddites, the Luddites are well known in England, trying to stop mechanization because it was going to replace jobs, destroying machines, killing factory owners. You can't stop the progress. And then today we have our modern day Luddites, right? Those are taxi drivers, one example. These are guys that are protesting against Uber and other things that are disruptive business models. You cannot stop the impact that digitalization and a connected world is going to have on businesses. So I know that was a lot to cram in, but I can assure you the digitalization of manufacturing is real, it's converging, there are going to be some winners and losers, and it's very important to start to adapt your thinking of products, supply chain, and how you approach markets. And with that, we will conclude on the presentation and entertain any questions. And James, I'd ask you to be the moderator.
Okay. This was actually good stuff. Folks, Mitch has actually opened up the floor for questions, so in the little box below, just type in questions that you have for Mitch. Anything and everything. Mitch, I do have another question. About a week or so ago, you were on a speaking tour, were you not?
I did do a couple of speeches, yeah.
Where were you at, and whom were you talking with?
I was speaking at a couple of supply chain conferences, and primarily about the impact of digital manufacturing on traditional supply chains. And supply chains have traditionally been organized in a very linear fashion. As Lean and Six Sigma came in, and we tried to optimize and minimize supply chains to have the most linear fashion, the minimum number of nodes, and we got extremely lean. But what we figured out is now we have to rethink that entire strategy, because as supply chains become more dispersed and manufacturing capability becomes like, as an analogy, printers on a network that we can distribute wherever, all of a sudden we have to rethink that. With the tools that we have today for managing over the web, with the technologies that we have for producing, does it make more sense to have a traditional linear locked-in supply chain, or to have a more disparate, fragmented supply chain? And so I do a lot of speaking about that and some thoughts around that. And the answer varies based on the company, their product mix, and their industry.
Okay. First question here we have is, will the major manufacturers pick up on this first, or do you think that more mid-sized and smaller manufacturers will move on this?
Yeah, that's a great question. As far as which manufacturers will move first, I think that we're already seeing it's the small and mid-sized companies that are moving first, because they tend to be more nimble. They have the flexibility to move. Unfortunately, that's just larger companies take longer to adopt. And if you want a real-world example of that, just go look at some of the products that are being started and funded on Kickstarter, or some of the other websites that are crowdfunding products. We actually recently helped a company that was funded on Kickstarter called Acoustic Stream. Acoustic Stream is a very cool product. They sold 500, and that was a good and a bad problem, because it has a plastic case and other components. And they were like, well, how do I make 500 when if I had to go build a mold for that, it would eat up all the money that I brought in on Kickstarter. And we've actually already got a better idea for the next design. And so we're producing these cases for Acoustic Stream by Additive Manufacturing, 500 sets in those cases. And so it's the new products, new companies that are thinking about that out of the gate. And in some cases, they're just sort of, it becomes an obvious decision as they look at the economics bringing a new product to market in low volume.
Nice. Here's an interesting one as well. What publicly traded stocks would you buy in this technology?
Well, that's a great question. And that's probably not the best advice to give, but I would probably, what I would look around that is, who is serving who are the real industrial players, around additive manufacturing, and there's a couple of players out there. I think Stratasys is right smack in the middle of this. I think 3D Systems is right smack in the middle of this. I think there's in the metals technology. There's a couple of companies. I think Renishaw is doing some really interesting stuff in metals. I think EOS is doing some really cool stuff. It's a little early in the metals. It's still a little bit of a speculative bet. So I think there's a number of players out there. I think the folks that are playing in the consumer low-end space are going to have a hard time making money over time. I think they're doing a lot to bring awareness to additive manufacturing. But I think at the price points that they put themselves at, and with the quality of the technology and the parts that they can make, they're going to relegate themselves to a maker style of parts or market, which is really cool. It brings awareness. It teaches people about 3D modeling and making parts and printing parts. But I don't think they're going to be able to make a lot of money selling printers 1,000 at a time. So I love those companies. I'm happy they're there, but I don't think I would be a buyer of their stock.
And just as a disclaimer, Mitch is an additive manufacturing guru and not a financial analyst. So
right, absolutely.
Another good one here is, what is the cost range of 3D printers?
Yeah, so they range from typically $1,000 up to $1 million, and so it really depends on size, quality, resolution. One of the things that layer thickness is a thing that we talk about in the FDM, the fused deposition modeling world, is as the additive manufacturing machine puts down layers of plastic or layers of metal, how thick are those layers? So it's just like resolution on a printer. So things that will affect the price are how big of a part do you need to do, what is the resolution of the part, how accurate do you need. So it will range from 1,000 to 1 million. I think if you want to produce really high-end injection molded quality style parts, you're looking north of $100,000. And the way I see this playing out is I don't see a lot of companies buying those printers. I see those going outside to additive manufacturing digital factories that will be able to provide the scale and speed that's needed. It just wouldn't make sense for companies to buy a lot of high-end commercial quality additive manufacturing machines and keep up with them as the technology evolves. It does make a lot of sense for companies to buy a machine of reasonable quality to have in-house, to do some prototyping, rapid product development, those types of things. But then when you move into that no man's land of low volume production, you probably don't want to go invest millions of dollars having high-end machines sitting around in your facility. And the other thing trend that I didn't notice, that I didn't mention earlier, that we see a lot, and that is people, when they come out with a new product now, we've helped a couple of companies where they're making the first 100 or 200 pieces by additive manufacturing, getting it out in the market, making sure that the market likes the products, there's no more tweaks that need to be made. And once a couple of hundred products are out into the market, then they're switching to buying tooling. It was a really good way. We see companies do that with introducing products introduction, And that really needs to be done with more of the higher end technology for your customers to look at that as a retail ready product.
Nice stuff. I want to thank Kenneth for that question and Gary's earlier on the stocks. The next one, Marco is asking, could you please expand on Onshape CAD in the cloud? Do we need to retrain designers currently using Pro-E? What are subscription costs per seat and security?
Yeah, so I will. That is a great question. So I have found Onshape. So first of all, let me start off to say I'm limited to what I can say about Onshape. It's in pre-production mode, and I do have a non-disclosure agreement about a lot of details, but I can talk about things at a high level. So I have found the usability to be exceptional, and I would consider myself a very good user of SolidWorks, an average user of Pro-E, and it took me a couple of hours to become an expert in Onshape. So they've leveraged a lot of the same user interface and user principles that you're familiar with from CAD. The pricing, they've not published that yet. I would say it's going to be right around the yearly price of what you would pay just for the maintenance, or less than the maintenance on the other systems. What you can do with it is really pretty phenomenal in a browser with no downloads. There's zero lag time. You're able to model, rotate, share, and I think this is absolutely the future of 3D CAD, and I think it's going to really challenge the business models of people that have been selling you software that's licensed and locked to one machine. That just doesn't make sense in this day and age. And I personally, disclaimer, I don't own a penny of stock in Onshape and have no vested interest other than I'm an evangelist because I'm using it. And I love the fact that I can use it wherever I am. I have a design at the office. I log out, I go home, I log into my computer, and I pick right up where I left off.
Wow.
That's pretty cool.
That actually, Marco, does that answer your question? If you have any follow-up, please type that in the box. Next question. Sue's asking, is the U.S. in a position to be a leader with this digitalization and therefore bring more jobs back to America, or do you see certain other countries taking a real lead to keep and gain business?
That's another great question. So I think certainly this is not limited to the U.S., right? And it's technology that can be repeated, business models repeated. But what I think bodes extremely well for the U.S. and what is really in our favor is the fact that consumer behavior and how we buy and consume products has changed. This desire for customizing, for on-demand, reduced inventory, shorter product life cycles, all those things, like if that's what you have to do as a product company to compete today, you cannot do that with a long extended supply chain on the other side of the world. You're going to have to make those parts, components, and assemblies in America to be competitive. And I think there are some really good examples of companies that are doing this. I mean, one company that gets talked about quite a bit is a company called Invisalign. Invisalign makes retainers, for the straightened teeth. And so that process happens where a dentist takes a digital impression, by a scanner, and then every single one of those retainers is printed on demand for each patient and shipped. It's faster. It's a great use of product customization. The margins on that is really high, and there's a lot of examples out there where people are figuring out how to do that. So I think the technology is definitely not relegated to the U.S. There are a lot of places around the world that are good with technology and will catch up with us very fast. I think the U.S. has the lead right now, but I think the consumer behavior is what's really in our favor, and I think businesses and business models have to really take advantage of that.
Yeah, actually, we did hear about the International Space Station getting their own 3D printer for spare
That's
parts
right.
as well.
Yes.
Now, next question is from Greg. And do you think this technology will be used by manufacturers to reduce spare part inventories?
Another great question. I absolutely do. Last 2 weeks ago, I was speaking at a conference, a supply chain conference in New York, and the gentleman before me was a chief manufacturing scientist from GE, and he raised a point that I wasn't aware of. He cited Ford Motor Company and a couple of other companies that are, as they design new models of cars now, and they do their prediction of how much they're going to need for inventory, for spare parts out into the future, or however long they support that product, that Ford, within GE, and a number of companies are curtailing their estimates on what they think they're going to need to overproduce to have an inventory to support the product lifetime, because they think that will be produced by additive manufacturing on demand instead of building a lot of parts and holding them in inventory for years. And so he said, and I have to believe that that's true, the companies are redesigning and rethinking how much inventory they're going to keep on hand to support cars, medical devices, and other things for the future, betting on the fact that they'll be able to leverage additive manufacturing to produce those spare parts on demand.
Oh, that's brilliant stuff. Are there any more questions? If there are any more questions, please type in the box. If not, Mitch, is there anything that you want to further talk about yourself, your business, the things that you've got coming up, planned for the foreseeable future?
Well, you know what, I just want to say I think, I know it's a valuable time that everyone took to be on here, and I really, really appreciate that opportunity. And I'm passionate about manufacturing and making things, and I love it so much. A year ago I went back into the business of making parts through machining and stuff. I'm getting my hands dirty every day, and I couldn't be happier about that. And happy to share, off of this. If anyone has any questions or wants to have a chat, feel free to email me or call me, and I'm happy to speak. And because I know everyone is on here because we all share a common passion.
Excellent, good stuff. Well, folks, just a reminder again, this is being taped, so if for whatever reason you had to log off early or you missed certain parts, the recording will be available soon. Once again, I just want to thank Mitch for his time and explaining an exceptionally interesting and compelling topic. I think a lot of us have only heard portions of it coming out from the media, but really was a real eye-opener. So I want to thank Mitch for his time. Also want to thank everybody that spent their lunch break with us. This was also, like I said, this will be taped and available. Keep a weathered eye out for further promotions because we've got another one coming up next week. But once again, you guys have a great day. Thank you very much. Talk to you soon.
Thank you.
All right. Bye-bye.